Good morning, students. So today here we discuss the adjoint and inverse of a matrix. So in our previous chapter, that means in matrices, already we discussed about the inverse of a matrix, is not it? So in this section, especially in this determinant part, what you have to do, actually we have to find out the condition. So that means condition for what? So existence of inverse. So when inverse exists, and for that what type of conditions are required here, we have to discuss. So that means if we consider a matrix A, for example, if we consider a matrix A and if we find out the inverse for this matrix A, so for this matrix actually we have to define some more topics. So in this topic, the first one is adjoint of a matrix. So at first here we have to discuss about the adjoint of a matrix. Only for that reason here the headline given here as an adjoint and an inverse of a matrix. So first of all, adjoint. So in this adjoint, let's see what we get here. Adjoint of a matrix. So here first of all we have to discuss this one, adjoint of a matrix. So let's take an example. So if we consider an example here, if we consider a 3 by 3 matrix, suppose if we consider matrix A and the matrix is this one, and here 3 by 3, some elements are here we consider. Suppose this one we write A11, this one we write A12, and this one we write A13. Similarly A21, A22, A23, and this one is we write A31, A32, and this one is A33. This one we write 3 by 3. So now in this case, all of you know what is the meaning of this A11. So here A11 means the first row, first column. So here 1, 2 means what? First row, second column, and this one is first row, third column. Similarly, if we check out another one, suppose this A22, what is the meaning of this one? So here we write second row, second column, and these are known as here elements. And here how many rows are there? 3 rows as well as 3 columns. So that's why here this one is known as 3 by 3 matrix. So if anyone asks you to find out the adjoint of this matrix, so first of all, what you have to do, we have to find out cofactors for each and every element. Is it clear? I repeat, for adjoint, first of all, what you have to find out, we have to find out the cofactor of each and every element. So here cofactors, first of all, here we have to find out cofactors. So how can we find out the cofactors? So generally the cofactor formula is, and this one is symbolized by like in this way, Aij, capital letter Aij, and here we have to write minus 1 to the power I plus j. This I mentioned here number of rows and j is the number of columns or the position of the columns. So minus 1 to the power I plus j, and with this we have to write this one is Mij. Now here this Aij is known as cofactor. Is it clear? So now here you see what is the name of this one in my channel. If you want, you get these cofactors and minors, because some videos are already given there. So this one is minor here, this one is minor. Clear? If you want cofactor and minor, how can we find out the minor and cofactor? Then easily you get this one in my video. So in my last video, I think this one is discussed cofactor and minors. So in this case, if you see here, how can we find out the cofactor? Here, if we consider this A11, let's see how can we find out the cofactor. So what is the position here? 1, 1. Is it clear? So the positions are 1, 1. So we have to find out the cofactor of, for example, A11. So how can we find out? So here for this A11, if we find out the cofactor, the position is 1, 1. So that's why we have to write this one is A11. Is it clear? Equals to, then here we have to write minus 1 to the power 1 plus 1. Clear? And then here we have to write the minor M11, because here Ij, here the position is what? 1, 1. So that's why here we have to write 1, 1. So how can we find out the minor here? For minor, what you have to do, first of all, you have to check out which element here we consider. Suppose here in this case we consider this element, is not it? So we have to eliminate this row or column. If we ignore this row and this column, then which 4 elements are remain? 1, 2, 3, 4. These 4 elements are remain, and these 4 elements are actually we have to write minus 1 to the power whole square, and this one is for minor. How can we find out minor? I repeat this one. For this A11 we have to eliminate this row column, so here these 4 elements are remain, and these 4 elements are we have to write A22, A23, and this one we write A31, and this one we write A32. So in this way actually we have to find out the cofactors, and this one is the minor. So in this way, for each and every element easily we can find out the cofactor, isn't it? So for example, if we want the cofactor of this A33, so what you have to do, this third row and the third column we have to eliminate, and which 4 remain? A11, A12, A21, 2, 3, and the power here row is 3, column is 3, so minus 1 to the power 3 plus 3 we have to write. So in this way we have to find out the cofactor. And then after that, how can we find out? So first of all, what you have to do, for each and every element we have to find out the cofactor. Is it clear? So after finding the cofactor, now here the adjoint. Generally the symbol of adjoint is this one, this one is adjoint, adjoint of A, and this adjoint of A equal to what you have to write? This one equals to, you have to write the cofactors of each and every element. The cofactors of each and every element. So first one is A11, so that's why here if we consider the cofactor is A11, then for this one we have to write this one is A12, and here we have to write this one is A13. Similarly this one we write here A21, and this one we write A22, and this one we write A23. Similarly here A31, this one we write A32, and this one we write A33. These are the cofactors. Clear? And this one is not complete here, and we have to, after writing the cofactor, we have to transpose the result, and this transpose result we can write in different way. You can write transpose of this matrix in this way you can write, or otherwise cofactors, and just you have to symbolize this one by dash. Dash is also represent for transpose, and similarly here capital letter T, as well as you can write small letter t also. That means we need the transpose of these cofactors. So that means adjoint of A formula is this one. First of all we have to find out the cofactors and then just put transpose T, or you can apply dash there. So better you have to write T, which represent transpose. So that means now we have to transpose the result, then finally we get adjoint of A here. So if we transpose this result, then we get adjoint of A. Now here if we transpose this result, so transpose means what? We interchanging the row and columns, is not it? So we have to write down the row as columns, or the columns we have to write as row. So now here if you check out one by one, so here the first row is this one, A11, 1, 2, 1, 3. So this first row we write here as a column. So that's why here we have to write this one is A11, this one we write A12, and this one we write A13. You see here these 3 are given here as a row, and now here we write these 3 as a column. So this one is known as transpose. So the second one is here, second row is this one. So here we have to write A21, and this one we write A22, and then here we write A23. Is it clear? Similarly the third row here we have to write this one is A31, this one we write A32, and this one we write A33. So this one is transpose. After transposing we get this result. So this one is known as adjoint of A. With the help of example, it is more clear to understand this one. How can we find out the adjoint? So all of you know how to find out now here adjoint, is not it? For example, if we consider a matrix, suppose let A equals to, suppose here we write 1, 2, 2, and 2, 1, 2, and 2, 2, 1. For example, suppose 3 by 3 a matrix given to us, suppose this one. And can you find out the adjoint of this matrix? Yes, easily we can find out. So first of all, what you have to do, for each and every element here we have to find out the cofactor. So that means what is the position of this one? A11, this one is A12, this one is A13. Similarly A21, 22, 23. Similarly A31, A32, A33. So with the help of this method, easily we can find out the adjoint of this matrix. Is it clear? So this one is for 3 by 3. So let's take another example here. Suppose here A equals to, if we write A equals to 1 2 3 4, suppose this one is the matrix here and we have to find out the adjoint here. So this one is 2 by 2, so this one is 2 by 2. So in this case, one thing you see here, this one is 2 by 2. There is a shortcut tricks to find out the adjoint of 2 by 2 matrix. All of you know this one. So in this case, how can we find out this one? Adjoint of A. So adjoint of A equal to, just here you have to see, let's see what you have to do. First of all, the first row, first column is which one? This one is, and first we have to interchange these two. The first row, first column and the 4 we have to interchange. So without doing this cofactor, if you find out the cofactor, then also you get the same result. So here first of all, what you have to do, the first row, first column element is here 1 and diagonally if you see here the element is 4, so we have to interchange these two. So if we interchange these two, then here we have to write 4 1, first step. Then the second step, what you have to do, the numbers are written same here, 2 here 3, so that means here we have to write 2 and 3. Just change the sign. Change the sign means here positive 2 is there, so that's why here we have to write negative 2. Here positive 3 is there, so that's why here we have to write negative 3. So if you do like in this way, so without doing anything, easily you get the answer. Is it clear? So I repeat this one. In 2 by 2 matrix, what you have to do, first row, first column and the diagonal elements, these two are we have to interchange. Is it clear? And the other two are what you have to do, write same number, just change the sign. If minus given, then you have to write plus. If plus given, then you have to write minus. Is it clear? So this one is about adjoint of a matrix. Is it clear? With the help of example here we discuss. So your task is what? You have to just find out the value here. What is the value of this A matrix here? Is it clear? So that's all for today. So in our next class, we have to discuss about the theorems as well as what is singular matrix, what is non-singular matrix, and after that we discuss about the inverse form. Is it clear? Okay.